Hello and welcome to today's webinar. I'm Jared Ruckel with InfoQ. Very excited to be here with Eric and Rohit from Harness. We're going to be talking about a very interesting topic here today, architecting enterprise-grade GitOps with OpenTofu, lessons from platform engineering at scale. I think this is an area we've all been interested in. Infrastructure as code, platform engineering, these are all patterns that we've been thinking about, GitOps as well. And there's a number of exciting developments happening in this space, as Eric and Rohit will chat with you about. There'll be some demonstrations, a poll question as well. Before we jump into it, a couple of quick housekeeping items. Your lines have been muted, but of course we are very interested in the questions that you have. So please use the question console within GoToMeeting to ask your questions, and we'll get to those if there's time towards the end of today's call. You'll also get a recording of this in your mail, so be on the lookout for that. And so without further ado, Rohit, Eric, welcome to the webinar.
All right, well, thanks, Jared. I'm really excited to be talking about this. I think it's a really important topic, right? As we're trying to deliver more quickly and more efficiently as organization, the foundation of what we're doing is infrastructure and making sure that we've got fundamentally effective and efficient environments. And so making sure that we can deliver this to our developers in a way that they can be self-sufficient while keeping in line with organizational standards, super important. So I think this is a really critical topic. So I've been banging around the kind of DevOps and infrastructure space for some time in a number of different roles, whether that's as a developer, product manager, technical marketer. So that's a little bit of my background. Rohit, do you want to introduce yourself as well?
Yeah. Hi everyone, I'm Rohit. I've been here at Harness for like over 6 years now, and it's been really interesting, my journey here, and would love to show you all the cool things that we've been doing here and talk a little bit about everything going on in the ecosystem as well.
All right, well, let's get into it. I think we got some important stuff, and title slides are probably not the most exciting. So how are we going to go about this today, right? We're going to talk a little bit about, Git and GitOps, what's going on in the infrastructure as code space, how that's all coming together. And then we'll use our own tool as a little bit of an example for how we're seeing GitOps in the infrastructure as code space and how we're seeing that implemented. But obviously there are other ways of doing it. So that's how we're going to go about it. But let's start with Git and the developer experience around that. And Rohit, like, developers love Git, right?
Yeah, absolutely, Eric. I think like Git is where developers feel at home. It just brings the clarity and it eliminates all the ambiguity. And at least for me, when as a developer, it just gives me a sense of calm. Just knowing that it's a single source of truth, be it for my applications or infrastructure. And the collaboration is always seamless. Like you just get comments from your peers, reviews, you have the approval process, everything baked in, your versioning is automatic, you exactly have the audit of who changed what and when. And just a tight feedback loop just ensures that the context switching is minimal, which just enables making all these changes intuitive and as effortless as possible.
Yeah, that makes sense. That makes sense. And like, I'm very much a retired developer. And so when I'm thinking about where I want to collaborate, it's not Git. But, when we want to have very much developer-centric workflows, trying to do a lot of this work in a Git-centric place makes a lot of sense. And so as we go forward, I think a lot of what we want to think about in this session and strategically for the folks on this webinar is who should be making decisions, and then what's the right place for that person to work, right? And if it's a developer, might be Git, right? And so that's going to be a lot of what we talk about here. Let's step away from that a little bit and talk a little bit about infrastructure as code and have some of the trends that we're seeing there. Early days, certainly configuration management tools. They wrote the first chapter of treating infrastructure as software, like particularly Chef and Puppet. When they popped onto the scene, they really set that standard for being able to script infrastructure into existence. And that was like, how do I spin up a VM and configure that virtual machine to be the way I want it to be? Ansible came, I think, a little bit after, at least that's how it felt like to me. And it's still going strong. Then we saw this rise of either cloud-centric solutions like CloudFormation, and then Terraform, which was cross-cloud, popping up after that. It was more declarative. And so we're seeing this more declarative model coming forth. And this trend of where that's going is what we'll be talking about in a little bit. But all of this is a as code approach to how we define our infrastructure. All right, I'm going to write code, whether that's in a declarative model or an imperative model, to get my code going. And because I'm writing code, I'm a developer of some sort, right? It's gonna live in Git, right? Because that's where developers work. So once our servers become lines of code, they're going to inherit everything we love about software development. We get our version control. We're going to get pull request feedback loops. We're going to try to do pipelines around this, right? And so this is why we're going to have Git as a natural nerve center for our application code and the infrastructure code. And so it's a natural place for kind of that full stack of the application, from infrastructure all the way up to app. So particularly now that we've got this deterministic model with many of our infrastructure as code languages, being able to declare in code and say, hey, this is what my infrastructure should look like, and then be able to apply that out there, it's really, really natural. So that really brings us to, I think, the most normal way of doing that today, and that's Terraform, right? And Terraform really, I think, set the bar for infrastructure automation. And it did this in a couple of ways. You know, one, it's cross-cloud, right? And when it popped onto the scene, cross-cloud was not just that it worked in AWS and in Azure, but critically that it worked in your data center, right? That it could work in a cloud and it could work on your virtual machines. It could play nice with VMware, right? So it would work back on-prem with VMware, and it could work with your cloud infrastructure, and it could be a common language across all of that. So instead of having this fragmented environment where I would have one tool for working in VMware and a different tool for working in AWS and a different language for working in Azure and a different language for GCP, I could have a common language for everything. That was super attractive. And then the other thing that made us all feel good about it is that it was open source, right? And so we could contribute to it. We could build providers for it, and there was a community that could build up around it. And so with these two things, there was this kind of flywheel effect. People contributed to it, and so it supported more and more stuff, and so it was better to use, and so on and so forth. So Terraform really became kind of the standard way of working. And over the last 10 years, it's been hugely effective for us. As much as anything has become a standard, right? The danger was, you know, that when I said open source, really didn't have a strong governance model. It was governed by a vendor, right? HashiCorp. And so everything was fine as long as HashiCorp stayed good and noble and kept it open source. And so we had this risk of like, what would happen if they chose not to? And well, they chose not to. right? And they kind of did the classic open source rug pull of making a license switch, and right, like the community didn't react terribly well to that, did they?
Yeah, it definitely didn't go too well. It just sent like shockwaves through the community. There was always this fear of vendor lock-in with HashiCorp like sort of governing this. But then that vendor lock-in fear just became very real. Like it was current, and like there was people were just questioning the future of this project. The open source contributions dried up. But community being the community, there was a swift action, and the Open Tofu manifesto riled up like tens of thousands of people in support. 150 plus companies came together, supporting this truly open source version. And it was just a Linux Foundation backed fork of the Terraform project, but same syntax, same ecosystem, and it just became a drop-in replacement. And more importantly, it just became a symbol of community resilience over the years.
Yeah, no, I think there's this joke of like I'm going to take my ball and go home, but the community took their ball and kept playing.
100%.
To a degree, left Hatchet behind and said, "You can take your ball and go home." So, what's happened since has been quite remarkable. I think you said there were 150 companies co-signed, a bunch contributing code, others contributing providers, others doing some marketing help. There's been a lot of support in a lot of different ways. Initially this was brought in under the Linux Foundation. The natural home for it was always the CNCF. That took a little while to organize, but since April, OpenTofu has been adopted into the CNCF. So I think it's where it belongs. And so that means that, it's got the governance model that it needs, right? So instead of having one company controlling it and saying, oh no, we're not going to add this feature to the open source because, we only want that feature in the commercial product and we want to charge you for it. Now it's like, oh no, this would be a great feature that everyone would benefit from. Let's roll it in, right? And so we're seeing, good backwards compatibility with the older versions of Terraform, but also really great innovative features that in real ways are making OpenTofu better than Terraform was. So OpenTofu has really kind of taken on that mantle of the open source cross-cloud infrastructure way of doing things. And it's doing a really great job here. So I think that's what we're seeing out there. And I guess we're curious if any of you guys are making this switch as well. So let's run a quick poll and see if you're considering or have moved over to OpenTofu. All right. No one's moving yet out of this audience. It's a lot of thinking about it. If you're using Terraform at all. Okay. So far. Cool. All right. Not a lot of commitment to Terraform. Maybe I talked you out of it. Or maybe Hashi's talked everybody out of it. All right. Cool. So let's settle there and let's turn back to GitOps, which I think is a really interesting model for a developer-centric way of making changes. There we go. So GitOps really, I think, is well known in the application delivery space, particularly in Kubernetes, right? Where you've got tools like Argo CD and Flux, which are kind of the open source base layer for GitOps, and then commercial tools of various sorts have gone on top of those base layers, right? So Harness, as well as many other solutions, will sit on top of those. But the basic idea of GitOps is that you have a declarative approach to doing deployments. So in Git, you have a file that represents the desired state of what you want your environment to be like, or some files. Right? Developers, if they want to do a deployment, are going to change those files, check that into Git, do a pull request. You're going to have a review process there. When that's all approved, you've got some sort of a reconciliation agent that's watching that and recognizes, oh, the desired state has changed. And my live environment no longer matches what we want to have. Therefore, I should change what's out in that desired environment and bring it into line with what we want. And so that will then run the deployment activities to change the environment. So we've got this kind of versioning of the desired state. Those files are immutable. And you've got this reconciliation process where you're doing some watching. All right, so that's the general approach. And this can apply equally well to infrastructure, where, again, your declarative state could be your infrastructure as code. You make a change to it, you do a pull request, that gets reviewed. You have an infrastructure as code management tool that's operating as that agent. It sees that the pull request has been completed and accepted, sees there's new desired state. It then runs your traditional plan, apply sort of actions to update the environment. Now, with the continuous reconciliation, you are also doing drift management typically. So there is some loop where you are checking the environment and seeing, has it drifted away from the desired state? In a pure GitOps situation, you're supposed to say, well, if drift happens, automatically remediate it and change it back. Even in the application world, there are a lot of people who say don't auto remediate. You should just let us know that it happens and let a human make a decision. In the infrastructure space, it tends to be even more true because we tend to be a little bit more paranoid about why did that change happen? Maybe that was a very intentional thing by an operator. And I want to take a careful look at why that infrastructure change happened, right? Maybe that was an intentional patch. So in that case, you still want to do the drift detection, but maybe instead of a automated remediation that just automatically happens, you want to alert a person who clicks a button to say, okay, go remediate it or don't. Right? So we might back off of a pure play GitOps, but a lot of the same general structure will exist. And GitOps is a pretty popular approach, and it's popular for a lot of good reasons, right? We like things being declarative, and we like things being deterministic. All right, that's really nice. In general, having to script out the changes and having to do a lot of imperative work is fiddly, it's error prone, it's not a lot of fun. So if we can do declarative and deterministic things, that's really, really nice. As Rohit was talking about earlier, gets a natural interface. And particularly as we're working with like Kubernetes and things like that, fiddling with YAML makes a lot of sense. As we're working with infrastructure, working with HCL code makes a lot of sense. It's a natural way of working, right? And then we get a layer of audit trail and that sort of stuff when we've got Git history, right? We've got some sort of history capture of who's making what changes, were they approved? That is a natural thing that happens with the pull request process, where I make a change, I say, will you approve it? And Rohit approves it, and then that comes in, right? So there's a lot of good stuff here. That said, there's also some new friction, right? The pull request process typically means I change code, and then the diffs of that new code and the code itself goes to Rohit. And he has to look at my code and say yes or no to the code. And that can be tricky to understand the implications of the code changes, right? Is it easy to detect that that S3 bucket that I added has a public IP address or not, right? Maybe, right? If I change the size of something, is the cost implication of that easy to understand? Probably easy to understand if it goes up or down, probably. Is it easy to understand if it went up or down a lot? That can be trickier, right? So we're asking the reviewers to make a lot of very important decisions, but we're not making it easy for them to understand the implications of what they're approving. And that's really unfair. So this is a big challenge that we need to address. We also have some guardrail challenges here. You know, if we've got policies like we always need to make sure that we've done linting, that we've run our security scans, that there's a whole bunch of things that happened, right, before the pull request. We tend to just make sure that our developers certify that they've done it in a pull request comment, right? And that the reviewer then checks those comments. Those sorts of guardrails don't scale, and they're hard to really audit. So there is additional risk there, both from an audit perspective and just actual risk that we don't do the checks that we need to do. So those are really our core challenges, I think, in infrastructure as code. Outside of infrastructure as code, we have some auto promotion challenges as well. So I think those are the key things. I don't know, Rohit, did I miss anything that you're thinking of?
No, I think, yeah, it makes sense. Like you said, if you just spawn off a PR to me, it's yes, I do make all the effort to make sure that it's right, it's efficient, it is up to all the standards, but it's a little unfair, like, and sometimes we all miss things, and it puts the infrastructure in a position of risk, like both from a security, compliance, cost angle. So yeah, obviously, like these are challenges that need to be addressed.
Okay, yeah. So I think from these challenges, we can kind of infer some of the things that we need, right, to smooth that out. We need a pipeline, right? So we want to make sure that we're not asking our developers to, you know, manually run linting and security scans and things like that, right? There should be some integrated automation that just makes sure that happens, right? Great. We need some sort of gating, right, to make sure that, yes, we ran a security scan, and if the security scan found something really bad, Rohit can't approve it, right? Like, there's some sort of governance that says no new critical problems go to production. Policy of code is really natural here. We've been doing that in the infrastructure as code space for a long time. Open Policy Agent is what the industry is moving towards. Sentinel's also fairly popular in this space. You know, HashiCorp did that for a while, but OPA is more popular now. But some sort of policy as code is the way to go. Decorating the pull request. So what we want to do is use our pipeline to say, I open my pull request and we run the security scan, we run infracost to figure out what the cost implications are going to be. We run our TF-lint, we run all of the things we want to run. And then the output of that helps us make our approval decisions should go where we make the approval. Now, if it's going to be a manual approval for someone like me, that should go into a graphical tool. If it's going to be into the pull request for Rohit, it should be decorating the pull request. We should add comments to the pull request with that information to make it easy. And that makes the pull review process fair and reasonable and more auditable, right? All of those good things. Cool. And then we also want to make sure that we've got pre-authorized modules, that, you know, we've got some sort of internal module registry. So that's all vetted and approved, and we can reuse good stuff. And so it's nice and safe and easy for developers to do infrastructure as code using components that we know work and are safe. Cool. All right. So those are the big things we need to make this work in a grown-up, reasonable, well-architected way. All right, so with that, let's pass it over for a quick demo of what this might look like as we put it all together. And I will click the Change Presenter button. And there we go.
All right, yeah, let's get into the fun stuff. Obviously, like I just wanted to start with a couple of, you know, harness concepts that work all of this magic behind the scenes to make that seamless GitOps experience possible for the developers. So to start with, the workspaces, like an IACM workspace is essentially like weaving together the configuration in Git and correlating it with what the real world state is. You can think of this as like a one-to-one mapping between a Terraform state file and a workspace. And as you can see here, we also have drift detection that Eric was talking about earlier, where we automatically detect the drift of what changed, and there's obviously flows to auto remediate it with or without manual intervention, depending on the use case. And as we get into the workspace, we show all of the resources that are being managed by this specific workspace. We also show the Terraform outputs or the Tofu outputs. You can also drill into a specific resource and see all the attributes that constitute this resource. Obviously, like all of this is gated behind RBAC, where only users having elevated permissions are able to view all of these attributes. And we also have this concept of an activity history, where we are listing all the activities that have happened on this specific state file over time. Like it can be a plan, it can be an apply, it can be a drift detection stage. And like in this case, we just captured an apply. And again, you can drill into each of these things and see exactly what changed and get into the specifics of what attributes of that specific resource changed as well. So it's a rather neat representation of like exactly like what has happened, and it gives you the flexibility and auditability over time. We also have a feature which allows you to actually do a difference in various versions of the state file. This is very useful in, you know, triaging any infrastructure changes that might have occurred, and, you know, just to see like which version was the last stable version and what changed between that and the current state as well. Obviously, like all of these things that I just showed is a representation of the Tofu state, but we need a pipeline. Like we talked about this a little bit, and how do we like orchestrate all of this, have conditional checks and balances, have additional security scans, and all of this baked into one unified interface. And that's where the harness pipeline engine comes in. This is a rather simple pipeline. This is just doing an init plan. It's doing a security scan for your Terraform code. There's an optional approval step in here where a user can come in, review all of the changes and approve them, and auto promote to apply, right? And this is just one piece of the puzzle where you can have a much more comprehensive pipeline in Harness, and this is a representation of what the art of possible is. So you have a CI stage here, which is actually building your artifact, testing it, and then pushing it to an artifact registry. And then there's this actual infrastructure stage, which is actually provisioning this infrastructure, and we've integrated a WizScan here. And then it's actually deploying those changes in the cluster we just spun up and the artifacts we just built into dev. And it can auto promote to QA and production based on approval gates and so on and so forth. So it's a very comprehensive, extensible orchestration engine that we have leveraged under the hood for infrastructure as code management as well. And the last thing, we touched upon this a little bit as well. We have integrated Open Policy Agent into every single component that we just showcased, the pipelines, the workspaces, where you can write policies, right? So a policy can be as simple as, these are my allowed EC2 instance types or instance families, and anything outside of this shouldn't be spun up. And these can get very granular, there are some allowed instances in dev environments, and there are some allowed instances in production environments. So you can customize it as you need. There's also a policy here which enforces additional approval requirements whenever the infrastructure cost is going up by more than 10%. There's also a policy in here which is security related, it's essentially checking for open ports. And also, we'll cover this in the next section here, but we also have a concept of a private module registry where you can host your own modules, and you can enforce a policy which says you can only use modules that have been pre-verified by the platform engineering teams and specific versions of it, so that it makes the usage seamless and only allows users to use the modules that are pre-authorized. So how do all of these constructs come together in the GitOps world, right? So as a developer, I'm just making my code changes, pushing them into Git, right? So what Harness does behind the scenes is it's able to weave all of these concepts together. It's able to run a pipeline with all of the policies, checks and balances that we just saw, and it's able to decorate this pull request with all of the context for the reviewer and for the developers. So the first thing it does is it's decorating it with the Terraform plan, right? So you don't have to leave your pull request. Your Terraform plan is run orchestrated behind the scenes and written back to the pull request, and you can exactly see what is being added, what is being changed, deleted, and also what's not being changed. This is very useful to just do a double check on if there are no side effects in terms of, hey, even if I'm not intending to change something, is it getting changed? You have all of your plan, you have granular details on what's exactly changing. You also have the information of the Terraform and the Tofu outputs. You exactly know what will be changed, unchanged here as well, and the OPA policy checks that we just saw. So what this does is, as you can see, it has done a check against the EC2 sizing policy, and because I'm within my bounds, it has passed. It has also checked and verified that I'm only using the modules that have been pre-published and vetted by the platform teams, and because I'm within that guardrail, it passed as well. But it throws a warning and for some of these other policies where I just have an SSH which is just open to the internet. And obviously, like you can change, there are different levels of statuses you can set. In this case, I've just set the policy to warn the users and not fail. But if I set it to fail, it will then become a required check before this pull request is merged. We also have the cost element where we are showing how the cost is increasing or decreasing with this change. And in this case, we were at $5 a month, it's increasing by $22, and this is my net new cost, and this is the percentage increase. And if you want to get into the details of what is exactly causing this increase, we give you like a detailed breakdown of what's causing this $22 increase. And obviously this is representative, but like when there are like 20, 30, 50 resources, this breakdown can allow you to pinpoint the specific resources that are resulting in this increase as well. So yeah, like once the reviewer like reviews this and the developers make the changes and they hit merge, the merge event of a pull request automatically triggers another pipeline in Harness, and it's automatically able to do the Terraform init, plan, and apply, and keep your real world state in sync with what was just merged. So the last thing I want to cover is the module registry. Like again, like we have the concept of a module registry where you're able to like publish and host modules within Harness. I've published like a bunch of modules that I used for my pull request that I was just showing. And one of the interesting concepts that we have with module registry is we've seen that when we are developing modules, there's a very important piece of actually testing if this module is going to break my existing infrastructure. And it's extremely important because like various developer teams trust these modules, and if there is a bug that gets introduced in a module, the blast radius is significantly it's pretty high. So we have this concept of a module registry testing framework where you're able to select you're able to run tests, right? So you're able to select which which account you want to run it against, what tofu version. And by default, we offer two types of tests. There's this integration test, which is actually going to spin up your infrastructure and then destroy it. And then you also have tofu tests, where if you have like tests written in the tofu's unit testing framework, we are able to orchestrate those tests as well and automatically publish that back into the pull request. But obviously these are the two default pipelines, but we see a lot of our customers like build their own custom pipelines for running these tests against these modules. And this can involve like a variety of different things that you would want to test against. Again, like how all of this comes together in a pull request is just like any other CI test. It reports back. So in this case, I made an error in my pull request when trying to update my module version, and my integration tests and unit tests have failed. This disallows me from merging my PR and makes sure that I have all the checks and balances in place before I'm able to release this new module version for consumption. Yeah, that's a quick preview, and obviously we have a lot of features that we haven't covered in this presentation, but yeah, happy to take any questions after this. Back to you, Eric.
Yeah, so just to summarize, we like GitOps. It's a solid model for infrastructure as code. I appreciate that you also showed the pipeline with the approval that was not a GitOps way. So the pipeline for me as a retired developer. So appreciate that one. But if we're going to have the developers kind of delegating that to them, we're going to do peer reviews the way we're going to do it. GitOps is probably the way to do that for peer review. And then if that's the case, then we want that sort of run a pipeline, get all the information, get it into that pull request. So they've got all the information they need right where they're used to working, right? So decorate those pull requests and always think about how do I want to handle drift. And then, yeah, you were showing things like testing modules, right? You were showing things like running security scans with Wiz, right, as part of a pipeline to push out infrastructure as code. Infrastructure as code needs pipelines, right? It just does, right? And so I think we always need to think about how do we deal with kind of infrastructure as code things like state file management, which you were showing, and pipeline stuff, which has traditionally been thought about as like a CI/CD thing, right? How do you bridge that, right? So I think we showed one way of doing it, but that's always got to be something that's dealt with. Is you got to deal with pipelines for infrastructure as code. There's automation, there's workflow that needs to happen for infrastructure as code. So those would be the key things I think for folks to take away. But yeah, we can break for Q&A from here.
Okay, fantastic. I think, yeah, folks, please, if you do have questions, please chime in using the Q&A console. And maybe while we're waiting for some of those to come in, maybe we can piggyback on the poll question results about those folks that were evaluating OpenTofu and just Eric Rohit, be curious on your thoughts about kind of the right way to think about that sort of evaluation. And you've talked about some of the kind of the key criteria to look for, but I wonder if you have any other kind of success factors that makes for a successful evaluation so people can decide what to do.
Yeah, I mean, OpenTofu is designed to be a drop-in replacement for Terraform, right? I think you see over and over again, like you on Reddit, a lot of people ask like, how hard was it? And the answer was, I did it in 10 minutes. And I mean, that's more true for like a workspace than it is if you're an enterprise with thousands. There was just a great presentation at KubeCon, I think the one in Europe by Fidelity, but they had some tens of thousands of workspaces, and they've got thousands of developers, and their platform team tried to figure out like, well, okay, how do we move everybody over in a non-disruptive way? And if you're a platform team, like that takes a little bit more forethought and planning and things like that. But they walked through it in a 15-minute talk, right? And I think they did the whole project in 6 or 9 months. When you're talking about a technology shift across thousands of developers and tens of thousands of things, like that's about as simple as it gets, right? Like that's what a drop-in replacement looks like. And yeah, this is as easy as it gets. I'm sure, like I've been a product manager, right? It's been my job. Like if I'm a product manager at Hashi right now, I'm trying to figure out how do I make this not a drop-in replacement in the future? Like I'm doing that. Like that's my job. So I would expect that at some point in the future that this will get harder. And so I would think about doing this sooner rather than later. I wouldn't say I'll think about this in 3 years. I think it's something to think about now-ish.
So the evaluation should be somewhat straightforward, but then complexity as you actually go through the migration, especially at kind of the scale of Fidelity, and maybe complexity is the wrong word, but just kind of, work to do.
Yeah, I mean, you're going to change something for lots of people, and that's always a thing. Yeah.
Okay, couple questions here, actually specifically about Harness, about rollbacks and how the platform supports that, and specifically, can you do a rollback if there's, someone that, deletes something, accidentally?
Sure.
Yeah, I think like we showed, like we have these versions of your state that are saved within Harness, and they're all like version controlled, and you can see the differences between your state files. And there are ways to automate rolling back to a specific state in a given point in time. And again, like it all comes back to the advanced nature of the pipelines. Like it's able to create these custom flows for you to be able to perform all these complex actions.
And if you're using Git, then you have a declarative version of your infrastructure sitting in history somewhere that you should be able to get back, and you should be able to, put that out there again. So, but we got your back if you somehow manage to lose it.
Very good. Well, maybe one other question that kind of leapt to mind as I was listening to the conversation is, is there kind of a business dimension to this? Do you need to kind of go up the food chain and justify, the type of pattern or transition that you're discussing here? What sort of the rings of impact as you kind of think about making this change with some of the other stakeholders?
Yeah, I think what we see, I mean, in a lot of organizations, you had, all the infrastructure as code being controlled by a handful of people in the cloud operations team or someone over in cloud or ops, something like that. And they're servicing tickets, right? And they're tending to be overwhelmed as the pace of change is increasing. And they're also becoming a bottleneck if you start talking to the application developer. And so there's a demand kind of materializing either from we can't triple the size of this team, or from a VP of app dev, like we need to deliver self-service to our developers. This ticket-driven thing is too slow, too frustrating, whatever. From either side, we need to move towards developer self-service for infrastructure, right? And so the business case tends to be save labor, right, for that centralized team and go faster for better, responsiveness to business needs and things like that. And also, if we've broken something, don't have an overwhelmed central cloud team who can't actually get to the broken thing. And then that central cloud team, who are our experts, should then be able to spend time actually architecting cloud systems instead of, dealing with tickets of, I need another test environment, right? They should be able to up level in the value they're delivering. So there's a lot of business value that you can kind of wrap around this. And depending on whether you're talking to the VP of cloud or the VP of app dev, it's going to shift a little bit what that story is, but those tend to be the elements for why you're going to have a wide a story around self-service for application developers to generate infrastructure as code. Rohit, what did I miss?
Yeah, I think you covered most of it, Eric.
Okay, fantastic. Well, that's all the time we have here today. So folks, see the QR code on the slide to get that custom demo on the books. Thank you, Eric, and thank you, Rohit, for the thoughtful presentation and demonstration today. On behalf of InfoQ, I'm Jared Ruckle. Thank you all for joining, and we'll see you next time. Cheers.